Welcome to Naughty Notes. We're going to review some linear equations, and let's use some easy examples. Make sure we got it down. We're going back to, we'll start with the easiest one, slope-intercept form of the line, y equals mx plus b. You remember this one? Hey, look, the b, that's the -7. So that means that this line passes through 0, -7. The intercept means, where does this line cross the y-axis? And it does so at -7. Now, you probably also remember doing this way back in the day. You did this rise over run thing. You said up 2 over 3. You guys remember doing that? You know, and that's just how you could find integral values, up 2 over 3. And remember, that's the same as saying, well, in the opposite direction, down 2, back 3. We're just finding points on this line. Then you use your straight edge. Oh yeah, you did. And you lined up. I would take the 2 points farthest away, like that one and that one, snap. And I draw a nice line there. Now again, the line isn't this stair step. The line is actually like this. It's this red thing. And of course, most of the values are, well, fractional, to be honest. The x and both the abscissa and the ordinate, the x and the y, are, fractional. But on these particular points, we happen to coincide with integral values, and that's how you've been trained to plot it. And a couple things to think about there. Remember, every point on here is an ordered pair. 0, 7, -7 satisfies this equation, as do any of the other values. Now, also, remember, 2/3 is a positive number, but so is -2 over -3. Down 2, back 3. -2 divided by -3. Hey, a negative divided by negative, positive. All right, now, I don't think anybody had any problems with that one, but just taking it way back. Let's look at a different form of a line. How about this one? Ooh, standard form. I always get the standard and the general confused. Now, most of my students, the first thing they do is they convert it into slope-intercept. And that's okay, but do you really want to be a one-trick pony? Sometimes the standard form's kind of cool. So, I said general. See, I told you I always got them mixed up. Get that out of there. AX plus BY equals C. And it's written where A, B, and C are whole numbers. So, another mistake, integers. They could be negative. So let's do this. Let's find the intercepts. Now, again, I gave you a softball, gave you an easy one. We're going to find it. Let's put in a value of 0 for x. We could calculate y. Well, it's pretty obvious what happens then. I mean, if x is 0, 5y equals 15, right? So y equals 3. That means that this line passes through 0, 3. X is 0, y is 3. Passes through the point 0, 3, or has a y-intercept of 3. Okay? Does it? And it has an x-intercept. So let's have a look at that. Okay, all right, moving on. Well, looks like I messed up there. Let's find the x-intercept. Let's make y equal to 0. And again, we'll say, substitute 0 for y, 3x is 15, and I've got an x-intercept of 5, which means it's going through 5, 0. Now, I could just, I suppose I could. I could just line that up and draw my line based on that. No, I don't like that so much. But I could also do this, and yeah, I guess we're lapsing right back into our slope-intercept. We're going to say, hey, we've kind of figured out that, look, from here to here, I'm going down 3 over 5. Hey, I can see it graphically, just like if I, say, manipulated the equation. So I'm going to go down 3 over 5 again, find this spot. And we know that in the opposite direction, that would be up 3 back 5, up 3, back 5. Hope I did that right. We'll see in a minute. And let's connect those dots and see if it's a little bit better. Oh, that's sweet. And you can see that. So I guess we did kind of cheat and find the slope, but we found it graphically. And again, if you did that with algebra, that's cool too. But sometimes you can just find the x and the y-intercept. All right, how about another example? We're just going to go through 7 quick ones here. And this matches your worksheet. Well, if you're in my class, or if you're a teacher in somebody else's class and you're borrowing my material, same thing. Okay, let's just do this one without all the talking business. We're going to say, well, that's pretty obvious. And I'm going to say that if x is 0, watch this, negative 5y equals 20. So y must be negative 4. Now, if y is 0, 4 times 5 is 20. And the same kind of thing, you can just read. In this case, you're saying, I can see what I'm doing. I'm going up 4 over 5. So I'm going to go up 4 over 5. In the opposite direction, that would be 1, 2, 3, 4, down 4, back 5. And those are the integral values that I'm going to find. And let's just let's take out our Sammy straight edge. Oh, beauteous. And there you go. Well, 3 lines down. Can we do another? Yes, we can. This is pretty easy stuff, but it's just to remind you, your y-intercept is 5. Let's just read it straight off of there. That's where the y value, when x is 0, y is 5. And as always, rise over run. Remember, rise, in this case, the rise is negative. It's down 3. It's over 4. It's down 3. Set down 3 and over 2, 3, 4. And, or, going back, up 3 and back 4. Now, as long as I didn't make a mistake, we'll see what happens here. Let's change the color. Let's go blue. Oh, yes. A beautiful line with a negative slope. All right. Old hat. Now, come on, how easy is this? So we'll do another one of these, and then we'll mix it up. So again, we're going plus 3, and we have a slope of negative 2, which is down 2 over 1. This may be, and if this bores you, you can always go down 4 over 2. Right? Down 4 over 2. Let's do this. Let's go up 1, 2, 3, 4, 5, 6, and back 1, 2, 3. So many ways we could find this. And let's take our line and see how we did. Beautiful. All right. Hey, enough of that slope-intercept stuff. That's pretty easy. You know, we're saving this up for the next video with the point slope, but there's 2 more topics I want to talk about. And that's these guys. Y equals 2. What are you going to do about that? You know, some of you folks are just guessing. Is it this way? Is it this way? Let me tell you the easy way to do it. Y is always 2. So I'm just going to imagine myself. I'm going to imagine that, you know, I've got a point over here. I've got a point over here. When x is 2, y is 2. When x is 3, y is 2. Y is always 2. If I just keep making a whole bunch of dots, it looks to me like what I'm making. What I am making is a, just keep going here. Looks like I'm making a horizontal line, doesn't it? And oh gosh, let me put in a few more of these. Oh, that one I had already established. Thought I had already picked one up here. Oh yeah, let's do this one. Now, I named 2 or number 2 of the points in particular because I want to show you something. This is actually kind of neat. By now you've figured out this is going to be a horizontal line. Let's make one of them x1, y1 and x2, y2. Let's confirm something. We know this is the equation for the slope. So I'm going to say y2, 2 minus y1, 2 over x2, 5 minus negative 7. Let's work that out. Does that work out? Sure. 2 minus 2 is, of course, the number 0. 5 minus negative 7 is 5 plus 7, which is 12. 0 over 12. Does that work? Is that legit? And the answer is yes, because 0 divided by 12 is 0. This line, this particular line, has a 0 slope. This line, you could say, therefore, is still in slope-intercept form. Y equals mx plus b. M happens to be 0. And this is a horizontal line. So you're going to see this a lot. Do we know the difference between these two? And I'm just going to connect them and say, yeah, that is a horizontal line. Make sure you know that. By contrast, we'll look at the other one. Now you're kind of guessing, well, you know what the other one's got to be, but let's go through it as if we didn't know any better. X equals negative 3. So that means, when x is 0, y is negative 3. When x is, when y is 1, x is still negative 3. X is negative 3, y can be 2. Y can be 3, y can be 4, y can be 5. Y can be anything. X is always negative 3. Now like this, it's pretty obvious which way we're going. And we're going to use these 2 points. Why? Because I already have them picked out. And I'm going to make this one x1, y1. Really doesn't matter which is which. And I'll make this one x2, y2. Watch what happens when we use our equation right here. y2 minus y1 over x2 minus x1. We're going to substitute 5 minus negative 1. That's y2 minus y1 over x2 minus x1. This time we get something different because we're going to do this. And 5 I can subtract a negative 1. That, of course, is 6. Negative 3 minus a negative 3, which is negative 3 plus 3 is, of course, 0. And then you say ruh-roh, because that is one thing you cannot do. You cannot. Do not pass go. Do not collect. You cannot divide by 0. This has an undefined slope. Therefore, this line is not or cannot be written in slope-intercept form. This is, of course, your vertical line. And let's just put a line in there and say, hey, that's kind of cool. And I'm going to put it all the way from here right down to there. Anywhere along there, the value of x is negative 3. And this is a vertical line, and its slope is undefined. And well, I guess that's it. We've blasted through 7 quick ones, and thank you for watching Naughty Notes.